All right, let's get into it. We all think we know lightning, right? That huge, brilliant, maybe a little terrifying flash of light in a storm. But what if I told you that the most powerful part of a thunderstorm, the actual engine that ignites the bolt, is completely invisible? Today, we're going to break down a pretty incredible new theory that's uncovered a secret, self-fueling engine hiding inside every single storm. So that really leaves us with this one central question. What if lightning's biggest secrets are invisible? For decades, scientists have been picking up these really strange signals from storms, signals that just didn't add up, hinting that, yeah, there's a lot more going on than what we can see. And it all starts with these incredibly powerful, invisible bursts that thunderstorms are constantly cranking out. And these are phenomena that are way, way stranger than just a simple flash of lightning. And this gets to the heart of the paradox. See, scientists discovered these things called terrestrial gamma-ray flashes, or TGFs. Now, gamma rays are the most energetic form of light in the entire universe. And yet these massive bursts were coming from parts of the storm that looked totally dark and were completely quiet on the radio. All of that power with no visible source. It was a complete mystery. And I mean, we're not talking about a little bit of energy here. The levels are just staggering. We're talking tens of mega electron volts. When NASA's Compton Gamma Ray Observatory first spotted these back in 1994, they were seeing bursts of energy millions of times more powerful than the visible light we see with our eyes. Just incredible. And then, just when you thought it couldn't get any weirder, it did. More recent observations found something brand new. Flickering gamma ray flashes, or FGFs. These are bursts of gamma rays that fire off just milliseconds before lightning, but they have absolutely no detectable radio waves, no light, nothing. They're essentially these dark, silent ghosts flickering inside the storm. And these gamma rays, they weren't the only mystery on the table. For years, researchers were also dealing with this just chaotic mess of unexplained electrical signals that were coming from deep inside the thundercloud. This led to what scientists started calling an alphabet soup of mysterious signals. You had these initial breakdown pulses, or IBPs, super strong narrow bipolar events, NBEs, and these energetic in-cloud pulses, or EIPs. They were all different, they were all incredibly powerful, and for the longest time, nobody could figure out how they all fit together. And just look at how fast these things are. We're not talking about long, drawn-out events. These are pulses that exist for mere millionths of a second. An NBE lasts for about 10 microseconds. That's a flash of immense energy that is born and dies in the blink of a cosmic eye. How can something so brief be so powerful? So how do you solve a puzzle this complicated? Well, it turns out a new unified theory proposes a single, really elegant solution. A powerful, self-fueling engine that just might explain, well, everything. The answer, proposed by Victor Pascoe and his team, is basically a feedback engine. The best way to think about it is like when a microphone gets too close to a speaker, right? A tiny sound gets picked up, amplified, comes out the speaker, goes back into the mic, and it explodes into that deafening squeal. This theory suggests that storms can do the exact same thing, but with gamma rays. And this entire amazing process hinges on one fundamental piece of physics, the photoelectric effect. This is the idea that actually won Einstein a Nobel Prize. It's pretty simple. When a particle of light, a photon, slams into an atom, it can knock an electron loose. And that one little freed electron, that's the key that starts this whole engine. Okay, so let's walk through how this engine works. Step 1, a little avalanche of high-speed electrons gets going inside the storm's powerful electric field. As these electrons speed up, they shoot out high-energy X-rays. But here's the kicker. They shoot them backwards. Now this is where the magic happens. Those backward-flying X-rays slam into air molecules and, thanks to the photoelectric effect, they knock loose new seed electrons, right back where the whole thing started. Those new seeds create new, even bigger avalanches, which make even more X-rays, which make even more seeds, and the whole thing just explodes in a chain reaction, creating this massive burst of energy in microseconds. So here's where it all snaps into place. This single engine doesn't just make one thing. It's like a master key that unlocks all those other mysteries we were just talking about. And this is how the theory cleans up that whole alphabet soup. The very same engine produces different results based on the conditions. Think of it like a car engine. At high altitude with a weak electric field, you just barely press the gas and you get a quiet little flicker. Those silent gamma ray flashes, the FGFs. But you go to a mid-altitude, you push the throttle a bit more, and suddenly you get a loud roar with radio noise. That's your strong, narrow bipolar event. It's not a dozen different phenomena. It's one engine, just running at different speed. And that throttle is incredibly sensitive. Just look at this jump. A tiny, just 10% increase in the electric field. That's like giving it just a little more gas. And the engine goes from a whisper to an absolute scream, pumping out 100 times more gamma ray photons. This sensitivity is what explains the huge range of pulse strengths that had scientists so baffled for so long. The theory also solves another puzzle. Why events happening way up high at the top of the storm seem to be longer and more powerful? And the answer is pretty simple. It all comes down to air density. Up there, the air is much, much thinner. This basically stretches out the entire process, allowing the engine to run over larger distances and for a longer time, which produces these bigger events. It all scales perfectly. So, okay, we've solved the mystery of the invisible flashes and the alphabet soup of pulses. But believe it or not, the biggest reveal is still to come. This engine might finally be the answer to the oldest thunderstorm question of all. How does a lightning bolt actually start? And this is the punchline. This photoelectric feedback engine, it isn't just some weird side effect of a storm. Scientists now believe it is the thing they've been looking for all this time. It's what they call the fast positive breakdown, the long sought-after mechanism that creates that initial massive surge of energy you need to kickstart a lightning bolt. This invisible engine, it's the match that lights the fuse for the whole show. And look, you don't have to just take my word for it. The authors of the study, they put it as plainly as you can. They say this work provides a unified physical mechanism for that whole confusing cast of characters, the IBPs, the NBEs, the EIPs, and the TGFs. It is the one elegant theory that finally brings order to all that chaos. It's really a stunning breakthrough, and it leaves us with one last, really fascinating thought to chew on. If we're only now figuring out the fundamental process of how lightning even begins, what other incredible secrets are still hiding up there, right in plain sight, deep inside the clouds? That's it for this explainer. Keep looking up.